We're joined today by Nina Lopatina from Unstructured.
I'm Nina. I'm a staff developer relations engineer at Unstructured. And today I'm going to talk about how you could approach evaluating RAG performance in a system built on your unstructured data. So we just do one thing, and that's make your human generated data machine readable. So we support a wide range of formats, and we kind of fit in this ETL stage before you want your data in vector storage or a knowledge graph or a fine-tuning platform. And so for today's tech talk, the tech stack is going to be unstructured, RAGS, GPT-4o, and we're going to be comparing llama 3.1 and llama 3 and using LangChain to stitch it all together, and it's going to be super easy. So where we fit in the stack is we do this kind of orchestration between whatever source your data might be living in. It might be in Google Drive or S3 or local on your computer, and whatever file format you have, we just take all of that and put it into JSON, and then we can chunk, summarize, embed it, and sync it to your vector database of choice or other cloud storage. And we process files with a few different sorts of methods. We do fast methods for files that contain text, and high res for image-based methods, and also third-party APIs for other features. And then we're going to be using RAGS for metrics for evaluating our RAG system. So they have a number of scores in their open source repo that they've developed. So they have a faithfulness score of how accurate the answer is, answer relevancy, how relevant it is to the question. And there's also retrieval metrics like context precision and context recall. And I think they added a few more since they made their initial little chart of metrics. And they also have answer semantic similarity and answer correctness. So we're going to be calculating all of these using their tools to both create the question and answer data sets and calculate the metrics. So the faithfulness score is how many claims can be inferred from the context over the total number of claims. The answer relevancy is the mean cosine similarity of the question to a number of artificial questions. And answer correctness is semantic similarity between the generated answer and ground truth, and factual similarity. And then we're using GPT-4o as the generator for the ground truth, for the question generation, the ground truth generation, and then as the judge. And that is simply because in the chatbot arena leaderboard, it is, at least when I made these slides late last week, it is still the most performant model. And so the tasks that we're having it do, really, ideally, you would have a human do them, but humans don't scale well. So this is the next best option. And then we're evaluating llama 3.1 because for me, it was very exciting when it came out last week. I am really excited about this open source development. And so they have made a model that really can compare with some of these top models that are proprietary in the open source. We're not going to be evaluating the 405 billion parameter version because we're doing everything in a free Colab notebook. We're looking at the 8 billion, but you could easily use the same approach for another model if you had some GPUs to run it on. And so these models have over llama 3, they have a longer context window, better tool use and reasoning capabilities, and they've also updated their license. And so from their own evaluations, the performance of the 3.1 series of models was intriguing. And so that's what we'll be evaluating.